Thank you, everyone. So I'm not sure if can you see the text clearly? Yeah. Okay, it's good. My name is Mohamed Rejeb. I'm an Android developer. I'm a Kotlin tech lead at Softlines. So my main work is Android, native Android using Kotlin, and also some cross-platform development using Kotlin as well. So today we are going to talk about shaders. It's something very niche, very specific. So do you have some people here familiar with web development? Okay, good. What about mobile development? Okay. And do you know what is a shader? Do you have any idea about shaders? Okay, most of the web and Android and mobile developers in general that I know doesn't know about shaders, but it's really something like it's really important, and if you know it, it's a good advantage for you. So we are going to learn the fundamentals of shaders today. So hope you are going to learn something very interesting. So what is a shader? Shaders, like I'm not sure if you can see the picture, but it's mainly used in gaming. You can build some really cool textures with it, some water shaders, for example, or whatever. So if you play any video game, if you see the sea and water and those stuffs, it's all built with shaders. But of course, we are not going to build something like that today. We are just going to learn the fundamentals. So the shaders is a program that gets run in the GPU, the graphical processing unit, instead of the CPU. So it's something specific that we can run into the GPU. So you may ask why the GPU exactly and why we even need the GPU for running shaders. Let's talk a bit about the hardware. So both GPUs and CPUs have what we have here, cores. I'm not sure if you can see the picture, but here we have the CPU and the GPU, and they have processing units. And the processing unit or the core of the CPU is much more powerful and faster than the GPU. But the thing is that the GPU have thousands of cores. So the GPU have a lot of cores, but the CPU normally have 4, 8, 10, or something like that. So here, like, we are going to render pixels. So if you are going to, for example, if you have a monitor 1080p, you have like basically 2 million pixels. So if you are running on 60 FPS, you need to render 120 million pixels each second, which is a very big number. And the CPU is not good for making these high intensity parallel programs. So that's why we need the GPU, because it has thousands of processors and it can handle these operations. So shaders is a code that runs on the GPU, and we use a specific language for that. Like you can't use any language. You need a specific one, which is GLSL, and that's the language that we are going to use today. So you can run shaders on Android, iOS, web, in Unity, in gaming, or any other gaming framework. So it can be used everywhere. So if you want to learn shaders, you can use GLSL editor, and it's the one that we are going to use today. You don't need any setup. You can just directly pull the shader code and run it. So it's really useful. You can just open Google and write GLSL editor, and you will find it. But if you're going to work with it on Android or iOS or web, you need to have some setup that you're going to do. But this is going to make things easier for you. Okay, so for shaders, we have different types of shaders. We have vertex shaders, fragment shaders, and geometry shaders, and so on. Today we are going to talk about fragment shaders specifically. So all the shaders have an entry point, a main function, and everything is going to run inside that main function. This main function is going to run for every pixel. So in your screen, if you have 1 million pixels, this is going to run 1 million times, but each time it's going to have different inputs. So the position of the pixel is going to be different, and you will need to return a different output, which is the color of the pixel. So your shader is going to get the coordinates of the pixel, and it's going to return the color of that specific pixel. So basically, you're going to draw the screen pixel by pixel in shaders. So here, for example, Okay, GLSL is a static type language, so it's like Java or C# or whatever. You need to specify the types explicitly. It's not like JavaScript. So here, for example, we need to set, like we have a width, we need to say that it's an integer. And for example, if you want to use a floating type, you need to set that it's a float and so on. Also, we have vectors. So most of the time, we're going to use floats and vectors. So we have 2D vector, which is an x and y, and we have 3D vectors as well, which is x and y and z, and we have 4D vectors, which is x and y and z and w. That's the most common types, and we are going to use them a lot in shaders. So for example, here we can create a shader, a vector, a 4-dimensional vector, and we can specify the values of x and y and z and w. Also, you can create it in a different way, so you can just specify a single value, and all the coordinates is going to have that same value. So here, 2.1, x and y and z and w are going to have 0.1. And there is something specific about vectors is that they have different names. So the x and y and z, they're also RGBA. So x is the same as R, and y is the same as G, and Z is the same as B. And why is that? Is to make the code more readable. It has nothing to do with functionality, but you can use vectors for position, and you can use it as well for colors. So if you're defining a vector for a position, you should use X and Y and Z. And if you're using a vector for colors, you should use RGBA for, so the code can be more readable. So if you want to create a color so if you know RGBA, you know that the RGBA colors have the red channel and the blue channel and the green channel and the alpha channel. If you're going to make this in GLSL, you are going to create a vector, and each coordinate is going to be a channel for color. So for example, here we have a color, and we are creating a vector for the vector for this color. And as you can see, we can access the red channel, the blue channel, and the green channel, and the alpha channel as well. So we have 0.1 for the red channel, and 0.2 for the green channel, and 0.3 for the blue channel, and 0.4 for the alpha. So of course, we need an alpha for the colors. That's why we have the 4-dimensional vector. Okay, now let's start drawing some colors. So usually when we learn a new language, we start with printing hello world, but printing text is not very easy in shaders. It's pretty difficult. So let's start with drawing some colors. Here is like we have this GL frag color, which is the final result of our function. So we need to set this frag color. What is the color of that specific pixel? So the color that we are going to put here is the color that is going to be shown on the screen. So as you can see now, we have this blue color, which is the result of the colors that we have, the 0 and the 1.0, 1.0, 1.0. Of course, we have a solid color. All the pixels have the same color in this shader, so that's why we have the same color. And we can see later how we are going to manipulate these colors depending on the position of the pixel. So there is something very important about shaders. The colors and all the values, basically even the positions, are normalized. They are between 0 and 1, so you need to make sure that all your coordinates are between 0 and 1. But for example, in RGBA, the values are between 0 and 255. So let's say, for example, that you have this color, and you need to have this color in shader. So you need to normalize all the colors and all the channels. So the red will be 255 divided by 255, which is 1. The green will be 0.35. The blue will be 0.56, and the alpha will be 1. So you need to make sure that all the values are normalized between 0 and 1. Otherwise, you will have wrong color. So this is very important in shader. As you can see, we put the same values there in the 4D vector, and we have the same color. Okay, now let's talk about precision. It's like we don't need to focus a lot about it in this level. But precision is basically like we have floats in shaders, and we have medium precision, low precision, and high precision. It's just to specify how many decimals after we can have in the float. So the higher the precision, the higher the quality. But you will need like it affects the performance. So we have lower precision, we will have a better performance. But we don't need to focus a lot about it. And also we have uniforms. This is really useful. We will use them a lot. We have 3 values here, which are the resolution, which is the size of your canvas. So for example, if you have the shader in a phone device, this will be the width and height of your device. Also you have the mouse position. That is like sometimes you open a website or a landing page, you have that random lines, and when you move the mouse, you'll have that like the lines are interacting with your mouse. So that's where you can use the mouse position. Also you have time, which is the time in seconds from where the program is started. So the time is useful for performing animation. So the time is going to keep changing each frame. So you can use it to make some animations. And we will see how we can use them later. Okay, now let's try, for example, to have a gradient with shaders. So as you can see here, we have a gradient from blue to pink. So let's see how we can draw this gradient. So here you have a frag chord, which is this one, the frag coordinates. And this one is the coordinates of the current pixel. That's how you can get the coordinates of the pixel that you are in right now. So now what we are going to do is, we want, if you are in the left side, we want the color to be blue. If you are in the right side, we want the color to be pink. And we want to mix them inside to have a gradient. So here, first we need to normalize this coordinates. So it's going to be, for example, if you have 100 pixels by 100, this one is going to be 100 by 100. So we need to normalize it. So we will divide it by the resolution to have a value between 0 and 1. That's the main important thing. Now we have a normalized position of our pixel. We can directly use it in the red channel. So as you can see here, we have in the 4D vector, in the red channel, we have the position.x. So this one is going to be, will go from 0 to 1. So if we see here, that's the positions that we are going to have. So by the way, the shaders is like, the start of the shader is from the bottom left. So the 0, 0 will be here in the bottom left. And we'll have like in the top left, 0, 1, x is 0, and the y is 1. In the top right, we have 1, 1. And in the bottom right, we have 1, 0. So the position x is going to move from 0 to 1. So for those pixels in this line, it will be 0. And then 0 plus a small amount of value. And here it will be 0.5. And here it will be 0.75. And here it will be 1. So it's going to change the value from pixel to pixel. And this way you can have this nice linear gradient. Okay, that's how you can use the frag coordinates with the resolution. Now let's see how we can use the time to make some animation. So as you can see here, this color is animating from red to black. So we make this animation using time and the sinus function and absolute value. So how we can make this? If you see this graph, the sinus is going from -1 to 1. So if you put the time here, the time will change, like from it's the time from the program started. So it will be 0, 1, 2, and it will change over time. So applying the sinus function to it, we will have this result over time. And as we said, like we want the values to be normalized. So we want the values to be between 0 and 1. So what we are going to do, we'll apply the absolute value, and we'll have something like that. So we will have values between the 0 and 1, and then we can use those values to make the animations. So now when we are using this value directly in the red channel, sorry, we have the red channel is animating from 0 to 1. So when we have, so in this here, when the red channel is 0, we'll have a black color. There is no red. And when the red channel is 1, we have a full red. And between them, like we have this nice animation. That's how we can use the time to perform animations. And we're going to use this a lot. It's used a lot in shaders especially combining the sinus function with the time. It's used a lot to make some very cool animations. Okay, now let's see how we can draw something. So we've been just putting some colors, but we didn't draw any shape. So let's see how we can draw a shape. And we are going to draw a circle to animate it later and to mimic some animation for reactive audio animation. So first of all, to draw a circle, we need a center for that circle. So here, let's say that we have the center is 0.5 x and 0.5 y. And also we need the radius. So let's say it's 0.2, the radius of the circle. So now we need to know for each pixel if it is inside that circle or not. So for example here, the pixel in the point A, it's outside the circle. And the pixel in point B, it's inside the circle. So we need to know if the pixel is inside the circle, we are going to set the color here to black or to the color of the circle. And if it is outside, we are going to set the color to the background color. So let's see how we can do this. So first, let's create some variables. We have the radius variable, which is 0.2, and we have the center, which is a 2D vector, 0.5x and 0.5y. Of course, we have always the position of the pixel, which is normalized between 0 and 1. This is the position of the current pixel that we are in. Then we need to calculate the distance between the current pixel and the center of the circle. So we can do that by subtracting the position by the center, and then we can use the length. We have a predefined function from shader which is called length that can help us to calculate the length of a specific vector. So here we have the length of position minus center, and it's going to return us the distance between the center of the circle and the current pixel. So as we said before, if this distance is lower than the radius, so we are inside the circle. If it is bigger, we are outside the circle, and we are not going to draw the circle. So how to do this? Things are different in GLSL. So it's made for performance and it's made for GPU. We can't use conditions, if-else conditions. Like in a normal program, we are going to make if distance is higher than radius or whatever, do something else, do other thing. But here it's all about mathematics. So we are going to use something called step. So what is this? The step function is like it receives two values, A and B. So in our case, let's say it's the distance and the radius, and it's going to return 1 if A is lower or equal to B, and 0 otherwise. So if A, which is distance, is lower or equal than radius, it's going to return 1, which means true actually. Otherwise, it's returns 0. So, and we are going to use this value to have like to determine if we are going to draw the color of the circle or not. So let's see how we can use this. Let's try to. So here we added this variable circle, which is step, distance, radius, and we tried to put it directly in vec4. So what this means, if we go here, if A is lower or equal than B, which means the distance is between the center and the pixel is lower or equal the radius, we're going to have 1. And if we have 1, that means white. So if you know, white is 1, 1, 1. And otherwise we'll have 0, which is black. The color black is 0, 0, 0. So that's why here we have this white color and this white circle, and we have a black color outside. Okay, now we don't really have control over this color, so it's just black and white. But what if we want to have like control, and we have custom colors for the background and for the circle? So let's see how we can do this. And to do this, we need another function. So we have a lot of predefined functions in GLSL. This one is called mix, and what it does is just mixing two colors. So mix receives two colors, which is, for example, let's say white and black, and it receives a float, which is the progress. So how much we are going to mix from each color. So if this value is 0, we are going to put white. If it is 1, we will put black, which is the second color. And if we're going to put another value in between, it will just mixes the two colors. So for example, if we put 0.1, it will put like 90% of white and 10% of black, and so on. So here, for example, we have 0, and the color is white, as you can see. So we have 0, and it's white. So it's the first one. And here we have 1, and it goes with black, the second one. And here, if we have 0.5, it will mix both of them, and we have a gray color here. So it's 50% white and 50% black. So this one, we can use this with step. So step is returning 0 and 1. So we can use this and step to have a background and circle color. So if we go back to our example here and add mix, let's go back and add the mix. So here we added 2 variables, a background color, which is white, and a circle color, which is red. So as you can see here, the red channel is 1, the other channels are 0, the blue and the green. And now we have the circle variable, which is the step. This one is going to be 1 when we are inside the circle and 0 when we are outside. And now we added this mix color. So here, as you can see, the circle is going to be 1. So if it's 1, we are going to use the circle color, which is the second one, which is the red, as you can see here. And if the circle is 0, we are going to use the first color, which is background, which is white, as you can see here. So using this mix, you can have more control over colors and have some custom colors. And yeah, so here, this is the background, the background color, and this is the circle color. Okay, now let's try to make some animations. Let's combine both things that we've learned. So we did some animation with color using Sinus later. Let's see now how we can use this to make some pulse animation and some scale animation to the circle. So as you can see, this animation here. So what we have here is we have Sinus, we have a complex function here for calculating the radius. So what we changed exactly is the radius now is not a constant anymore, but we changed it to be dependent on time. So we have this value, which is speed. This value is going to determine the speed of our animation. So I think we need to clarify this more. Just wait a second. Let's make a better explanation of this. So if we go here to Desmos, so here if we type, let's have a function, let's have x. So here we have like a normal sinus function. That's the function that we have. We said that we have a multiplier here, which is the speed. And why this is a speed? Because when you have x inside the sinus, when you make like this multiplier higher, so the bigger this value is, the higher the speed. So as you can see, the frequency of the sinus changed, so it's going to make our animation faster. And if we want to make it slower, we can put 0.5, for example, and you can see it's like we have a slower animation now. So that's why we are using this value as a speed. So we can control the speed of this animation by changing this value. So you can just put the value that you want. Here we have +1. Why we have this one is because, again, as we said, so we just want the value to be higher than 0. So, sorry, here we're adding +1. Let's change it back to 3. So we want the values here, like here by this change, we have the values between 0 and 2. So we're going to have only scale up animation. We're not going to have scale down animations. And then what we have another value, which is this one. This multiplier here is going to multiply the full result, which is 0.025. Why this one? It's just for making the result smaller. So it controls the limit of the animation. It controls the maximum radius. So if we go here and we have, let's add this. So 0.05. So it's just going to make the animation a little way much smaller. And why is this? Because as we said, like our range is 0 and 1. So that's how the animation is going to be. Like if you have bigger values, like we're not going to even see the animation. So Let's go back. Sorry. So let's go back to the presentation. So as you can see here, so the result of this function is that small animation. And here we have the base value, the base radius, which is 0.2. So we are adding this animation to the base radius. So here, as you can see, you can define this value by calculating the maximum radius. So if this value is 0.025, we can have the maximum radius is 0.25. And why is that? Because the result of the same function, the maximum result is 1. So we can change this with 1. And we have 1 plus 1 multiplied by 0.025 plus 0.2. It will be equal to 0.25. So you can change this value to define the maximum radius that you want in your animation. So this animation is going to animate between 0.2 and 0.25. And you can just play around with the values to define the maximum radius that you want. Okay, so now we can move this to make it more readable. We can move it to a separate function. So here we have this circle function, and let's have correct better names for those variables. So we have the base radius, which is the main radius of the circle without any animation, and also we have the speed of the animation, and this amplitude or amp, which is the multiplier that we're going to add, which is going to control the maximum radius that we're going to have. And we're going to use it later to make some bigger animations. And this one, the position of the pixel. Of course, this function needs the position of the pixel to draw the circle. And it's going to have this radius, and we'll do the same logic as before. The center is 0.5. The distance, of course, we can move the center to a parameter if we want to change it. Like if you want to have different center for the circle. We'll calculate the distance, and we'll use the step to check if it is a circle or not. So now our main function will be much cleaner. As you can see, we have the radius 0.2, the speed 3.0, and the amplitude is 0.025. And we just call the function here, and we draw the color. And we have the same result, but it's much cleaner now, and it can be more readable. So now we can use this function to draw another circle. Let's have a bigger circle, but with a less red color. So as you can see now, with combining those two functions, we can have this animation, and you can add like as many circles as you want. You just need to play around with the values, and you will have like some cool animations. So it's just about creativity now. So here we have a bigger radius, as you can see, 1.6, I guess, no, 0.35, and we have a lower speed, and like we played around with the values to have the animation that works best for us. Okay, so that's the animation that we have in the end. So as you can see here, like the main thing is not the animation. That's like something very, very basic. Like if you want to do it, for example, in JavaScript, you don't need those like much calculations. But the main important thing is the normalization between 0 and 1, the mix functions, the step, like all of those concepts of shaders. Like you can do a lot of things with it. So let me give you an example here for. Oh, sorry, there is another detail here, which is drawing both of those circles. So how we did this? We have first a color variable, which is the background, and then we have a mix, which is mixing the color and the color of the circle 2. So what it's going to do is going to draw the circle 2. If you are in the circle 2, it's going to draw the color of the circle 2. Otherwise, it's going to draw the color, which is the background color. Now we are going to have another mix, which is going to draw the circle 1 if you are inside the circle 1. Otherwise, it will keep the same color as before, which may be the background or the circle 2. So this one, like we can have a chain of mixes to draw multiple objects. So this technique is really important because like if you don't use it, you can override the circles. So you need to define if you are outside of both circles, we are going to draw the white color. If you are inside the second circle, we will draw this red color, transparent red color. And if we are inside the first circle, you will draw the full red color. So you can do a lot of more complex animations with shaders. So this is one of the examples. I'm not sure if it's really visible, but as you can see here, there is some animations, some noise animation in the circle. There is some glow, some rotations, a lot of things. I'll keep the link for this shader in the slides. Also, I'll give you a link for a website called The Book of Shaders. It has a detailed explanation and tutorials for shaders. You can use it, it's really useful. Yeah, so there is a lot of things that you can build with shaders, and it will give you like much more powers. So give it a try. This is the QR code, and you can here scan it, and you'll go to the shader that you saw and the book of shaders that you can use to learn shaders. Thank you.